Hey everyone, welcome to Topical Bytes. In this topic, we are going to talk about the binary system. Before I discuss about the binary system, let's look at the decimal system first. What you are doing when you're counting every day is in the decimal system. So what's the decimal system? The decimal system has 10 digits, ranging from 0 to 9. So when you count, you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after that, the next number will be 10, and then 11, and so on. So what happens is when you go to the number 11, you have two digits. You have a digit 1 and a digit 1. So you have two digits. So how do you go from one digit to another digit? How do you know when to add another digit? You add another digit to the left of your number when you go into an overflow. What is overflow? Overflow is when you have reached the limit of your digits. For example, in the decimal system, your limit is 9. So once you have reached 9, you will then add a 1 to the next digit. For example, if I am at 99 and if I will count the next number, I will then go back to overflow and restart at 0. When I overflow, I will add 1 to the next digit, and when I add 1 to this digit, in this case, coincidentally, I have also reached the limit and I will go into overflow, and then I will restart at 0 and I will add a new digit, and this digit will start at 1. So 99, the next number will be 100. And this is what we call the decimal system. Now let's take a look at the binary system. In the binary system, I only have two types of digits, which are 0 and 1. So how do you count in the binary system? Let's start with 0, and the next number in the binary system is 1. The next number in the binary system is, I need to overflow now, so I restart at 0, but when I do that, I add a new digit here, which will now start at a 1, because I can also say that this initially starts with a 0 and 0. Just like in your decimal system, you can say that this is 0, 0, 0, 1, 0, 2. It does not make a difference. It is still 2, 3, 4, 5, 6, 7, 8, and 9, and so on. So I can add a 0 in front. It does not make any difference. So in the binary system, likewise. So now I add 1, I will reach 1, 1. Now if I add one more, it will now be an overflow. So now it will become a 0. Add a 1 to the left hand side here because there's an overflow. Now it becomes overflow. Again goes restart to 0. And because there's a restart to 0, I need to overflow. Add a 1. Now it becomes 1, 0, 0. So then I can rewrite everything again to make it look nicer. Then I can say this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and so on. So this is how you go about counting in the binary system. But all these numbers won't make sense if we cannot relate back to our decimal system. So how do we convert between decimal and the binary system? So to convert from the binary system into the decimal system, let's take an example of a binary word. So this is called a binary word, which means that I have 4 digits to make up my one number. The first value here is actually 2 power of 0, 2 power of 1, 2 power of 2, and 2 power of 4. So 2 power of 0 is equivalent to 1, 2 power of 1 is equivalent to 2, 2 power of 2 is equivalent to 4, and 2 power of 3 is equivalent to 8. In this case, the value in the decimal system is equivalent to 8, 1 of 8, plus 0 of 4, plus 1 of 2's, plus 1 of 1. And then we have the value of 11. So 1011 in the binary system is equals to 11 in the decimal system. And this works actually very similar to how you count in the decimal system. Let's say, for example, you have 987. How do you get 987? It's actually 900 plus this place will be the tens, so you get 80s, and the ones, 7 of ones is 7. So that's how you get 987. Likewise, in the binary system, you have the ones, twos, fours, eights, 16s, 32s, and so on. And then you add them up, you get the value in decimal. Now, if I have the value in decimal, how do I convert back to the binary system? So now we have the decimal number of 11. Let's convert it back to the binary system. First of all, we start by taking the number 11, dividing that by 2. So when you divide that by 2, I will get a remainder of a 1. I get a quotient of 5. So 5 times 2 gives you 10. So you have a remainder of 1, or you do need to plus a 1 to get back 11. So when you divide this by 2, you get the quotient 5 and remainder 1. So we will continue this on. Now we divide by 2 again. Dividing this by 2, dividing 5 by 2, I get a quotient of 2. 2 times 2 gives me 4. I need to plus a 1 to get back a 5, which means I have a remainder of a 1. And I divide this by 2 again. 2 divided by 2 would give me 1. And in this case, 2 times 1 gives you 2. So you don't have to plus anything. So there's a remainder of 0. And finally, I will divide this one more time by 2. And if I divide this by 2, I will get a quotient of 0 with a remainder of 1. And once you reach 0, that's the end of it. Do not write anything here. And how do you read this number in the binary system? What you do now is then read from bottom upwards so that you would read a 1011. So this conversion from 11 in a decimal system to the binary system, you would get 1011. So remember to read from the bottom to the top, and then you get the number in binary system. And that's it. That's how you convert between the decimal and binary system. And this is the 4-bit binary system. This is called as one number or one word. In each of these words, there are 4 bits. 1, 2, 3, 4. So we call this the 4 bits. In total, there will be 16 words. How do I know there are 16 words? Due to 2 power of 4. So if there are 2 power of 4, 4 because of 4 bits, 2 power of 4 gives me 16 words. You can count there are 16 words including 0 to 15. So there are total of 16 words in a 4 bits binary number. You can of course increase more bits to increase your range of values that you can reach. And that's all for the binary system.